Hmm. Hello everyone. So today, we are going to see about single linked list. So we will look into how we need to develop a code for this single linked list and its working, like how it will work as a logic part or something. So single linked list is a basic form of you need to know how to define a class in some functions. So single linked list consists of nodes, maybe a number of nodes. So the single linked list is some kind of array. Array is something called, like, we have an inbuilt function in Python like called array, but in single linked list, like, we are creating the array. That's what the difference between the operations and like what needs to be performed and how it needs to be performed and all, like we need to give it there. So um single linked list consists of something called nodes. So we declare this node. So we call this block as a node. So you can also call it as an element also, it is whatever you can need. So in Python regular terms, like we call this each rectangular box is a single node. So in this each rectangular box, like we have two different separations. One is value and one is next. So has value has something called the storage, like what we need to be stored, and the next part will have an address of this next cell, like next node. So this next will have the address of this block entire node. Okay, so we have a value again here, and then this next. So this next will have the address of this next node. So how will we declare this kind of thing? So what we will do, we will define a class first. We will initiate this entire node as a entire block as a node. And then what we will do, we will define its like a value to null and next is equal to null, and then we will keep it. After we have something called like operation, like append, insert, push, pop, and then print or something. So we will just call this functions, and then this kind of thing can happen. Okay. So okay. So what will we do? Always this single linked list or a linked list basically have a header part. So this is the main part. Like you need to keep an eye on this header part, head part. So this will be declared as self dot head. What it will say now, like this self dot head is something called a initiating point. So whenever your function calls, like if this self dot head is like shifted to this block or this block, like what will happen, like it will act like this block is a starting point, this node is a starting point, and it will do the remaining works like that. So it is very useful, like you need to have it this self dot head as a like in a correct position or a value. So this was the basically like a single linked list will do. Single linked list means single way direction, that is only from left to right, or something called in a single direction. So you can also assume it like right to left or something. So it will only carry the next value to in a single direction, and it won't have you don't have a redirecting to backwards or something. So it is something like that. So what is the value of this last node? So you can ask this question, like This last node will contain a value called a none or null. Basically, it is none. So we will define this value as none. So all the operations will be like considering like this. So if you once see this code, like how will we define something called linked list? Like you can assume it very easily, like how to define it for a single linked list. So single linked list is some kind of basic linked list. So you can have operations like append, inserting between two nodes, insert, and then like you have something called push. So push is in the index of 0, and then pop is for like something like you delete something from the last index, and then at last like you print, always a print an array. So for printing this linked list also, like you need a function print, something called print. So we will discuss about this 1 2 3 4 5 functions in this video. So this function is like written by me. So I know like how, what, and all like errors like what I have faced when I like was editing this some kind of code. So we'll start with something called defining. So first we will use this SL, that is single linked list, equal to single linked list. So we will define a class called a single linked list. That's it. So we'll just define it. So what it will do, so single linked list starts from head, right? So you need to initiate like a def underscore initiate self dot head like equal to null. So initially like head should be null. So like whenever you are starting a program, this linked list should be like empty. So you need to append it, or like you need to do separate functions then and then. So it will be like increasing its value. So initially like self dot head is null. So what it will do, we have a operation called append one. So I'm just appending 1 and 2, like so that my like playlist will not be like empty whenever I am like using something. So what it will do, it will call for append and it will pass a new data. So the data means the value which I'm passing. So the here the one is called a value. So the value which I'm passing is 1. So here like I will call this as a new data. So what I will do, I will declare this new value as a new node. So I need to have it as a node, right? So how this append will work now? So whenever see this, so whenever this, okay, so whenever you need to append or something, so append happens only at the last one. So maybe like we will something. So so we will have this block. So but we only have a value called 1 right now. So what we will do, we will create a node. So that what's node happens here. So what we are doing, we are calling this append and we are calling this new node equal to new node or new data. So this class node will have this new data, like it will create a node which has a value called our value, that one, and self dot next is none. So what it will have, it will have a value as 1 and this next, that is none. So it will have a value called none. So what we will do now, our entire this block is ready. Like we need to append this this thing now. So what we will do, we will just assume like first we need to check, right? So if we check whether this node is empty or not. So if it is empty, it is easy. Like we can just away declare the self dot head equal to new node. Like we are assuming like let's consider like this. We only have this node. Okay, so we only have this node with a value 1 and next equal to none. So what we will declare, like we don't even have a like our self dot head is like empty. So what we will do, we will say directly declare this self like this new node as self dot head. That's it. So leave it about this part. So whatever we are doing is like we are just away declaring this new node as a like our new array. That's it. Like a new liquid list. So else we return. So okay. So else part is like what we need to do. We need to like move on to the last node. So like we have to write a function like we need to penetrate to every element line by like every node by node so that until we reach the last node like last node that is not like that is empty. So we need to like have something called a temp. So this temp will have the self dot head the pointer. Like what we will do, this temp is something called a imaginary pointer or something. So what it will do, this pointer will have a imaginary value called temp here. So what it will do, this temp will have the self dot value. If temp dot next equal to not none, so it will go for temp dot temp next. So it will this temp will keep on moving from this value to this value, this value to this value. So if this next equal to null, so this temp will stop here. So our temp will go until its last value. So our temp will stops there. So now what we need to do, we need to append the last node here. So like what we will do, like we will assume this temp dot next to our new node. So what we will do, this is our block now. So what we will do, this is our block now. So leave it about this part. So this is our block node. So what we will do, we will declare this next value to this value, this to new value. And then like that is what we are doing. Temp dot next equal to this new node. This is something called a new node. Something called new node. So we will assume this temp dot next. Where is this? This temp dot next equal to new node. And then what do we need to do? We need to set this node equal to null. That's it. So what you will do, temp dot next equal to new node and this new node dot next equal to null. And then like this is for just confirming, like I'm just printing this appended value as new node dot value, like the last node new node dot value. So I'm just for giving confirmation. So I think this is clear. This append function is somewhat clear. So like what have I did? So I have a in Python, like we don't have a switch kind of operation. So I'm using elif for functions. So for append print for print. So we will now go for this print function. Print function is somewhere like similar to like append or something. If self dot head is none, like we need to check, right? So if self dot head is none, so we'll just away print this linked list is empty, so we'll return it. Else, like what we will do, like I'm just printing for elements and with an end of double quotes. So we'll just again have a self dot head is a temporary pointer. So we need to just check, right? So temp dot next is not none. So we what we will do, temp dot value. We will be just printing this temp dot value, and then this pointer will be like moving one by one till the last. So what this line will do is, like this line number 79 will do is, this while loop will run only up to, like, if say like we have a length of 5 elements in our linked list. So this while loop will run until only 4 elements. But the fifth value, what it will do, it will go for this fifth value and then check at last, like it is going for this fifth value, and then it will check, right? So it will check right away, right? The fifth value dot next is not none. So obviously the fifth value of next, it will be none. So what it will do, it will not even print this value. It will directly declare a breakpoint there. And then like what I'm doing is, actually my pointer is now it is in fifth value. So I'm just away like printing this temp dot value and then returning. So this is the logic behind this line. So I have experienced this kind of thing now. So again, we have a function called pop and push and insert. So push and pop or something called push is something called like we need to open it on initiate. So I think if you see this function, like you can understand. And pop is something called you need to delete something from the last, so it is also like easy to understand or something. So like we will go now for insert something. So what we will do, insert has two kind of values, like where we need to insert and what we need to insert. So we will explain with this thing. So insert will work. So So what we will do, we will have this kind of thing here. So we need to insert a new node. So again, like if we are like passing a value, we need to call this node, and then we need to create this value as a new node. That's it. So we will have a next value. So now this value is like created as a new node. So what we will do, we just created it, and then we initiating this local that I'm passing it as a string, so I'm just having it as an int. So for number counting number of occurrences, like I've used this count. So like what we will do, I'm just thinking like, so have it insert in kind of second place, insert this value something called 5. So sorry, let's have it as 6 or something. My bad. So let's have it as 6 or something. So in place of 6 second index, value should be like 6. So what we need to do, self dot like we can just have it a pointer or something. So starting index like 1. Mm, and then like you can have it like 0 also, like it is your thing. So there is one logic between count to 1 and 0. So if you have this count as 0, what it will do, it will insert its appropriate position. Like let's say you have a array. Okay, coming to this next point. So if you have this count, and then you are like increasing it, you are just verifying like this count is equal to like your local. If it is matches with your location, like the input location which you have given. So what it will do, it will just previous equal to next dot node. So it will just take ping a position. That's it. So what it will do, it will just ping up position like a temp. That's it. So for a temp, like we have having some kind of pointer. So for this also, like I'm using like what to say, we have a position, like we are using something called previous. That's it. What is previous or something. So what I'm doing is, so new node dot next equal to previous dot next. So what I'm doing is, I'm just taking this new node dot next equal to this thing, this value. So what it will do, it has this value. So this thing will go here, and then it will go for this call. That's it. So what I'm doing here, it is lying here. So previous dot next equal to new node. Okay, so and then again I am assigning this previous dot next equal to this new node. That's it. So what will happen? This bond will automatically break. That's it. So like what I'm inserting is I'm also like deleting this. So this is the operation behind insert. But this operation behind insert is something called insert after. So we are like, yeah, having a two. So it is not inserting in the place of second, but it is inserting in place of second after, like something called this. So what it will do, if you reduce your count value to 0, so it will occur for this in the current location. So we will have a array called something called, let's say we have a array. So in this array, so we will just have something, some point. So this index is something called, so my index is something called 1, 2, 3, 4, and then 5. So we will have just for our clarification 9, 6, 7, 8, 6. That's it. So what this count will do initially, like count is 1, so it is checking for a 2. So count is less than 2, so it will go for 2. And then if count is less than 2, no, it is equal to 2. So this pointer is like my pointer, like it is pinged here, this in this second position. And then my pointer will have a next value. So all these operations and all, it is like assuming. So eventually, like what is happening? So it is happening like my count, it is obviously like inserting in between 2 and 3. That's what it is happening. So you can also just edit this count value to your opinion, and then you can just away, like you can also like use it, this insert for insert after and insert before or something, or insert in the current location. That's it. So it is just a way like editing this count and locations. So that's for like for this linked list. Thank you for watching.